Page 25, lesson 1-4 is on square roots and cube roots. And so we're going to figure out how to evaluate those or find the value of those. So on page 25, Matt and his dad are building a treehouse. They buy enough flooring material to cover an area of 36 square feet. What are all the possible dimensions of the floor? So area of 36 square feet, and we're looking for possible dimensions of the floor. And this is for the flooring material is covering 36 square feet. So first of all, when we talk about dimensions, we need to know what that means. So dimensions, that would be the length and the width. So the length and the width of the floor is what we're looking for here. It says it covers an area of 36 square feet. We're trying to find the length and the width. So let's think about what this floor could look like that would give us that area. And an assumption we're going to make here is that our floor is either a rectangle or a square. Either case, to find the area of a rectangle or a square, we would take length times width to figure our area. Okay, so our area is 36, and we're trying to find possible length and width dimensions that would give us this area. So basically what we're trying to do, we're looking at, this is length times width. We're looking at two numbers we could multiply together to get 36. So one option you might have thought of is if we have a perfect square, 6 feet by 6 feet. That would be one option that would give us this area of 36. Another option, thinking about 36, again, if we think back with our multiplication facts, we could have 9 by 4 or 4 feet by 9 feet. Could be our dimensions. Another option as we think about this, we could have our treehouse, it could be 1 foot by 36 feet. Now to give you an idea on that, 1 foot by 36 foot, the tiles in this classroom, those are 1 foot by 1 foot. So if you can imagine basically a line of 36 of these tiles all right lined up with each other, that might be a little hard to get around that in that treehouse, a little hard to walk around, right? Another option, still maybe a little hard to work with, would be 2 feet by 18 feet. And I think we got one more. And so our final option would be 3 feet by 12 feet. Now, we look at those, we have 5 different options there. We can think about which one is practical for us to have. We talked about 1 by 36 might not be real easy, especially if you're not the only one up in the treehouse. And then we can also think about, besides that, we can think about which would have a bigger perimeter and which would have a smaller perimeter, and then we'll talk about why that matters as well here. So with the perimeter, the reason that might be important to us is if we're going to put a railing up, which would probably be a good idea on a treehouse, to put a railing up, whatever the perimeter is of our treehouse, that's how much railing we need to put up. Okay, possibly if you look at the picture, you know, maybe minus a spot that you can have a ladder to get down. Although even you could put a ladder there or a railing there and maybe have it be more like a gate that you could open if you wanted to get up or down. Okay, so if we look at these, and we'll go through and think about the perimeters, and I'm just going to write inside of these shapes what the perimeter of each one of them is. Remember, perimeter is the distance all the way around, so if it helps you, you don't have to do this, but if it helps you, you can write the dimensions on all four sides just so you don't forget anything. So this would have a perimeter of 24 feet. The 4x9 rectangle, we got 4 and 9 is 13, and then we'd have another 13 on the other two sides. That would add up to 26 feet. This next one, the 1x36, if you add all those four sides together, that would be 74 feet. That's quite a bit. The 2x18 rectangle perimeter would be 40 feet. And finally, the 3x12 perimeter would be 30 feet. So if you look at the different options, besides maybe seeming to be the most practical, also the less perimeter would be the 6x6. The 4x9 is not too far off. Another consideration would be the further out this goes away from the tree area, it might be harder to support it. We might need more supports and things so it didn't fall when we're standing up there. One other thing just to mention, we didn't really talk about it here, but there's nothing to say we couldn't have decimal dimensions. So for example, if you had an 8 by 4.5, 8 times 4.5 also is 36. So that could be another possibility as well. But notice the big variance in the perimeters, especially we get into like this here, 74 feet. That would be a lot of material we would have to have for the railing. So the closer to a square you have, if you have a square or as close to a square as you can get, it's going to be less railing. Another application would be if you're putting up a garden, or if you're putting up a some kind of a fenced-in area for a dog or something. The closer to a square, you're still going to give the same area for your garden or for your dog to run around, but you won't have to have as much fencing material if you fence that in. We're going to actually first look at the key concept, which is on page 28, and then we'll come back to the example problems. So on the key concept, they talk about what a cube root and what a square root are. And maybe if we want to start with a square root, might be something we're more familiar with. Square root is a number whose square is equal to that number. Or another way of thinking about it, it's what number times itself equals that number. So square root of 4 says what number times itself equals 4. So square root of 4, that would be 2, because 2 times 2 equals 4. Similar concept is a cube root. So cube root of 125, notice it almost looks like the square root symbol, except it's got a little 3 here. So cube root of 125, instead of a number times itself to equal that number, it's what number times itself 3 times equals that number. So to get the square root of 125, we're thinking of 3 factors. They have to all be the same that we multiply together to get 125. And that ends up being 5. 5 times 5 times 5 equals 125. One thing with a square root, you probably won't hear said too often, but with a square root, they don't put it there, but you could actually put a little 2 there on a square root, just like the cube root has a 3. It's just that square root is so common, it's maybe laziness, I don't know. They just don't even bother to put the 2 there. But you could technically put it there if you wanted to. On your calculator might be different than my pink one here, but on your calculator, there's ways we can do the square root and the cube root. So to do the square root, you might have done this before. Square root, you can do the second button, and then there's an x squared button. Right above the x squared button, there's the square root. So if you do second and then that button, and then type in whatever it is you want to take the square root of, that'll give you the square root. To do cube root, what we're actually going to do is you're going to start on a cube root by putting a 3, typing a 3. So if you type a 3 and then the second button, and then there's a button here, they call it sometimes a caret button. And right above that, you'll see there's a little X, and then kind of a radical, we call it. Kind of looks like the square root symbol, but it's got an X inside of it. So what that means is that number you type first, that's the root you're doing. So you type a 3, and then you do that, that means cube root. Okay? We won't get into it, but if you would do a 4, and then that symbol, that would be a 4th root, which by extension you guys can probably figure out that'd be a number times itself 4 times to get that number. Okay? So 3, and then second, and then this button here with the X and the radical, and then type in what you're going to do a cube root of, and then you can get that answer. So with all that in mind, now if we look at example 1, Leah is building a birdhouse for purple martins, birds that prefer cube-shaped birdhouses. What are the dimensions of each square piece of wood Leah needs to build the 216 cubic inch birdhouse? So these are pretty picky birds if they're only going to take a cube-shaped birdhouse, huh? Okay, so what we can do is think about it is 216 cubic inch birdhouse. Cubic inches, that has to do with the volume of something. So the volume is 216 cubic inches. If it's a cube, that means all 3 length, width, and height are all the same. So that's why they put an S there. So volume is length times width times height. But length, width, and height are all the same. So they said, well, instead of LWH, let's just put an S for all those. And then if we have S times S times S, that's the same as S cubed. So if S cubed equals 216, in order to figure that out then, we're thinking of 3 numbers that are all the same. When we multiply them together, we get 216. That sounds like we want the cube root of 216. So that's what we can do. So cube root of 216 actually ends up being 6. 6 times 6 times 6 equals 216. Okay? Now some of this stuff, especially bigger numbers, we might just use calculators for that to figure out what those cube roots are and things. We could do it by hand, but just to make it a little quicker for you. So what that means is the dimensions of each square piece of wood are 6 inches by 6 inches. So altogether we've got a 6 by 6 by 6 birdhouse, but each individual face, each individual side of the birdhouse would be 6 inches by 6 inches. So on the try it, similar idea, we have a cube-shaped art sculpture, has a volume of 64 cubic feet. What is the length of each edge of the cube? So it's a cube shape, means length, width, and height are all the same. So basically the same idea. We could go through these steps if you wanted to. Okay. And the idea is if something cubed equals 64, if we find the cube root of that, we can figure out what just that side length is. So the answer to this ends up being 4. Cube root of 64 equals 4. If you were filling in these boxes, they would actually all be 4s. 64, we could do 4 times 4 times 4 to get 64. And so that 4 times 4 times 4 is the same as 4 cubed. And then kind of the idea here is it's like the cube root and the cubed cancel each other. That's another way of thinking about this. Anyway, the length of each edge then would be 4 feet. 4 by 4 by 4 cubed. And again, if we weren't allowed to use the calculator, if we were just trying to figure this out by hand, we could just guess numbers. So maybe you try 5. So you multiply out 5 times 5 times 5, and that ends up being 125. Well, that's too much. Maybe you try 3. 3 times 3 times 3, that's 27. That's not enough. So it must be in between there. And then we can hope that 4 works, and it ends up that it does work. Okay? So again, it's not the end of the world if we didn't have to use, or if we weren't allowed to use calculators, we could still work it out by hand and still get these answers.